Okay. Today we want to look at the topic of functions. So want to look at functions. What are functions? Functions and what are functions? This is a very important topic as far as mathematics is concerned, especially at advanced level. Functions plays an important role. So want to define functions and understand the language of functions, because majority of the students fail questions on functions not because they don't understand the concept, but because they don't understand the language of functions. So I've designed some notes and I'm going to demonstrate using some examples. So I want to look at language of functions. Then later on we'll look at composite functions and inverse functions. We need to know the terminology associated with mappings and functions. Let's start by defining a mapping. A mapping is any rule which associates two sets of items. In a mapping, the input or object is something which is to be mapped to something else, which is the output or the image. What we mean there is we have an input, for example 1, which is to be mapped to give us a what? An image. So this is a what? An input. This is an input. Then we'll have output. So mapping is a rule that maps this to give us an image. Let me go back to the definition. A mapping is any rule which associates two sets of items. That is the input and the image. The input and the image. So what we mean here is that we can have what we call a function. For example, y equals to 2x plus 5. This is our rule, the rule that we are using to map the input to give us the image or the output. So if one is mapped, for example, if you look at this function here, whatever value of x that we input here will result in a new value which is termed y. So x becomes our input and y becomes our output. Okay? So x becomes our input here. Okay? to give us the y value, which is a what? Which is an output. So if 1 is inputted into this, we'll get y equals to 2. Then where there is x, we are inputting x here, right? Such that y is equals to 2 plus 7, which will give us 9. Therefore, our output value, or the image for 1, is what? 9. Let's talk of, let's have another example as our input. 3. 3 will give us an output value of, we put 3 there, becomes 2 times 3, which is 6, plus 5. We get 11. So this is a demonstration, a clear demonstration on what is mapping. So the mapping is a rule, like n given function or an equation, a function that translates the input to the output value. Okay? So the set of all possible objects, that is all the inputs of a mapping, is called the domain of the mapping. And the sets of all outputs for a particular set of inputs for a mapping is called the range. Basically, what we mean here is that all these values, which we call the input here, they can also input is the same as domain. This is now the language of what? The language of functions. Instead of us using the term input, we can use the term domain. Okay? Then from the definition again, we'll see that all the outputs, meaning these values which will produce the images or the output, we said the output values is the same as the image that will produce, which is also the same as what? It's called the range. Okay? It's called the what? The range. Just like what we agreed on here, that domain is also equals to what? To input. So output the same as the image or the what? The range. So all those sets of values which will produce as outputs or images are called the range. So let's meet in the next lesson, where we are going to look at types of mappings, the types of mappings. Thank you very much for being with us on our platform. Please remain subscribed.